We're diving in still in lesson 10.3 with today is measures of center. And then next time we'll talk about measures of spread. That'll make a lot more sense what a measure of center is compared to a measure of spread when we kind of get all of it down. But the measures of center is like how things just like vary from a typical value in the data set. And it's the big three. It's the mean, the median, and the mode, right? The mean is the average. You just add all those bad boys up and divide by how many you had. The median is in the middle, which we've talked about a couple times already, but remember they have to be like written in numerical order. And then the mode is the most occurring. Again, you could have more than one mode, right? So sometimes that does happen. But the mean, the median, and the mode, we've talked about that a few times, and you did that back in middle school, so they shouldn't be new words to you. But today we learn more about them. So first, here it is. Can we realize that we got a dot plot here, and it says it shows the travel times of 20 randomly chosen workers in New York State. To be clear, it's not New York City. It's the entire state of New York. Are you with me on that? So they just randomly chose 20 people. They said, yo, man, how long does it take you to get to work? So this person right here, could you tell me, how long does it take for them to get to work? 5 minutes, right? And you can see the rest. They say find and interpret the mean, the median, the mode. Bro, I don't want to calculate all this. Let's let the applet do that for us. So if we go to Canvas, on the agenda, I have the link for data needed. So we got to go to the agenda and click this data needed. Make sure you're on the 10.3 day, not on the 10.2 day, right? So we're here, just click that. I got all 3 questions that we're going to need data for, like our practice worksheet on here. So this is not on here. Isn't this, are you with me on that? It is not on there. So we will copy and paste other bits of data. It's okay that we don't have it. I have the summary statistics for us, so check it out. Pretend that I actually put this on the spreadsheet so we can copy and paste, and then we copy and pasted it in there. Would you believe it would give us the summary statistics, right? So I just messed up. My bad. What's the mean? 31.25. But they also say interpret it. It's always fun to say, what does the mean mean? Like, we're going to bring the magic word in. Isn't mean about average, right? So this means this. Like, the average of these 20 randomly chosen workers, travel time to work was 31.25 minutes. The average of the 20 randomly chosen workers in New York State, travel time to work was 31.25 minutes. So, all right, that's what the mean meant. It's like, hey, these 20 people that they randomly chose from New York State, they averaged about 31.25 minutes travel time to work. What's the median? Can you tell me? It is 22.5. And median to us means what? I say median, you should think one word. Starts with an M also. Median means the middle, right? So would you believe if that was the middle, then like half the data is on one side of it and half the data is on the other side of it? So here's how we'll kind of word that. That like about half the travel times were more than 22.5 minutes and about half were less. About half the travel times were more than 22.5 minutes and half were less. And then how about the mode? What does mode mean to us in English? The mode is the most occurring, right? Are we cool with that? The most occurring. Which one is the mode? It doesn't tell us in the summary statistics. You have to go to the graph to see it. Which one's the mode? 15, right? You know, so a travel time of 15 minutes occurred the most. Travel time of 15 minutes occurred the most. A travel time of 15 minutes occurred the most. That's what the mode meant. If there was more than one mode, you just list them both. You know, it's like, oh, 15 minutes and 27 minutes occurred the most. You know, you just list them both, right? Or all that good stuff. Describe the shape. That's what we did last time. So I personally am a big fan of drawing this curve. Let's discuss with this. How many peaks would this bad boy have? One peak. Is it fairly symmetric, skewed right, or skewed left? Those are the big 3, unless the other ones are like fairly uniform or bimodal, you know, and it's like this is definitely not bimodal since we just went through that. So tell your neighbor, what do you think? I think it is skewed right. Cool. You know, are you cool? Because that's where the tail is, right? Remember the tail. If it's on the right, it's going to be skewed right. Is there any gaps? What would you think? Any gaps? Some gaps. They're not big gaps, right? You know, here's a decent gap. You know, there's a gap there. There's even a gap there. Sometimes the gaps are small. Sometimes they're big. But there's some gaps, right? And, like, do you feel that there's any outliers, just out of curiosity? Is there possible outliers? Yeah, probably 85, right, you know, I would say. So I said skewed right, many gaps, possible outlier at 85. That's probably too much information for when they say describe the shape. The answer should just be like skewed right. But I wanted to get a little more detailed since they didn't ask us to do true SOCV and like do the shape, outliers, center, and variability. So skewed right, many gaps, possible outlier at 85. And here's a little preview on part E. They're just saying, hey, which measure of center, what I need your brain to start recognizing is when they say measure of center, they're asking mean, median, or mode. Are you cool with that? Mean, median, or mode. Which measure of center do you feel best represents the data? We don't know yet. We haven't learned, so it is guessing time. Do you think that the average was the best, the median was the best, or the mode was the best? Discuss with a neighbor. What's your thoughts? We're a little unsure. I'll make a better question. What if we put all our ages into the applet, myself included and Miss Watson included, right? We could find the mean, we could find the median, we could find the mode. Which one do you feel would be the best to represent the typical age in this classroom? I don't think it would be the average. Would you agree with that? Why not? Because I am an outlier. I am an outlier, which would skew the data. Are you with me on that? It would skew the data. So does this have some possible outliers? What do you think? We were saying maybe 85, right, you know? So I don't know if the average would be the best one. Does that kind of make sense? The average might not be the best. I have a little more experience. It's cool if you had something else, but I think that the median would do a job. And it'll turn out that what we're about to learn would make my guess correct on that. Median is the best. Why? So here's a cute little chart right here. Check out this guy. Could you describe him as fairly symmetrical? Isn't that very symmetrical data? So what happens is the mean, the median, and the mode will all be just about equal in that case. I want to see if I have that. No. They're all about the same. If you have fairly symmetrical data, the mean, the median, and the mode are almost the same number. It doesn't have to be perfect, but almost the same. What's the best measure of center? We usually go with the mean because the world likes to think about averages. It's like, oh, their average was this, their average was that. The truth is, it doesn't matter. They're all almost the same, so you could have chose the median, you could have chose the mode. This rarely happens. Would you believe if we collected data, it is probably not that normal to like have fairly symmetrical data. It is usually skewed. So check this guy out. Here, isn't this data, which way is it skewed? Skewed to the right. Here's where these things would be. The mean would be closer to the right because doesn't that outlier over there pull it up? Just like if we did our averages of ages, my age of 44 totally brought up the average of our ages in this classroom, so it made the mean get bigger. The mode is at the peak. Doesn't that make pretty good sense? The mode is at the peak, and the median is somewhere in the middle of the data. So here's what happens. The mean is usually, hey, what's that symbol mean? Greater than or less than? Greater than the median. The mean is usually bigger than the median, and the best measure of center to really do a good job is the median. And here's why. You'll learn that's the theme of the day, is because the data was skewed. Right? If the data is skewed, we're going with the middle instead of like the average in this case. So what do you think about this? Is this also skewed data? But since it's skewed to the left, would you believe that the mean gets pulled to the left even further? So it makes it smaller. That's like if I wasn't in here and somebody had a 2-year-old come into the classroom, right? Isn't that an outlier on the low side? It's going to pull the average down in that case. So the mean is typically less than the median. But the best measure of center is still the median. Moral of the story, bro, if you've got skewed data, we're using the median. It would be a better representation of the data in that case. If it's skewed, we're using the median. And then here, the very rare, like, bimodal data to where it's like almost like two symmetrical things, like what would be the best measure of center in this, would use the modes. The modes. Like if it was bimodal, it's like, okay, you could have a really low age. Maybe you had a bunch of like first graders in here and a bunch of ninth graders in here. You'd have to kind of use both of them to describe it, you know. It's just like, okay, the average age is either like 6 or 16, or you know what I mean, or something like that. So it's kind of a lot of, I shouldn't even have said average age, but the age should describe it the most. So. But this is a very weird situation. You don't have that happen too often in the data we look at. So let's do it. I do have the carrots data on that spreadsheet. So let's go and just learn how to copy and paste again into this. So here it is. They made a dot plot of it. I want to do it anyway, so we'll go to this. Here's the carrots. Just copy it. And then you could go to your applets. If you don't have the applets bookmarked yet, you might want to bookmark it. Otherwise, it's on the agenda right here. Just click that. And then you do one quantitative variable single group. You don't click the collaborative link, though, because that's only when we're doing stuff together in class. I want you to all do it. If you had an applet open and you just wanted to go back to the menu, if you scroll all the way down to the bottom, I guess I have to be inside of one also, so we'll do that. So we'll paste it. But you see there's a link at the bottom that says go back to the menu. So we'll paste that in and begin the analysis. And it makes the same old dot plot that I had on paper already. I don't even remember if I had it on paper for you. Don't think so. I just had it. Yeah, I did. I had it there. But let's see if we can answer these questions. Describe the shape of this graph. One quantitative variable, single group. That's what we did. One quantitative variable, single group. Here it is. What do you think? I kind of missed the peak there. But does it have a peak, yes or no? Yep, but not much. So, again, the less data you have, sometimes the harder it is to describe. I'm open for suggestions on how you would describe this data. What would you think? Let's start some things. Is it fairly symmetrical? I don't think so, because where that one peak is, would you believe that the dots, like the tail on the right side, is longer than the tail on the left side? So I would probably rule that out. Skewed right is a possibility. What's another possibility? Fairly uniform, you know? Like, I can't argue with fairly uniform, but since it did have a peak, I'm going to call it slightly skewed right. Okay? Slightly skewed right. Sometimes you just got to look through your drop-down menu, like if they talk about single peak or double peak, you know, so I just throw that single peak in there. It's up to you. I don't need you to write the single peak part down, but when you're doing homework, sometimes it's like, oh, is it single peak or double peak, you know? And then find the mean and the median. I think we got that in the summary statistics, right? Mean was 50.5. I want to show you something that homework might start using. Mathematicians do not like to write, so instead of writing out the word mean, sometimes they put this. They call that X bar. That's the letter X with a bar over the top of it. That is shorthand for mean, right? So if you ever see X bar, that's your average right there, 50.5. And then the median, they don't have a symbol for it. They just abbreviate it to 49.5. Which one better describes this data? Here's how I rule with it. Was our data skewed? Yes. So what's our answer? Median, right? Median. Even though they're still really close. They're only 1 gram off in this case. We're going to go with the median because the data was skewed. Because they say explain. Because the data was skewed. I don't even care about the word slightly. You know, it was in this case slightly, but it's because the data was skewed. That's the moral of the story. If your data is skewed, we're going with the median. Cool. All right, let's switch it up a little bit and do this. First of all, I got these typed in a bad order. There's parts A, B, C, D. We got to do part B last. So we're going to skip B and do it last. But how many runs does the Lawrence High School baseball team usually score? Here is data on the number of runs scored in all of their 21 games played in a single season. They say, calculate the mean number of runs scored. Please go back to the spreadsheet, copy that data, and put it into the applets. So what you can do, instead of reopening a new window every time, like you're done with this applet, scroll down to the bottom and hit back to menu, and it'll take you back. And you can just keep using that same one. So one quantitative variable, single group, and I got to type in the runs scored. So this is a high school baseball team. They played 21 games, and we wanted to record all of this data. So hopefully your dot plot looks the same as the dot plot that was on paper, or at least on your computer screen. Mean of what? 4.14, and a median of 3. So a mean of, lost it. Thought I had this. Oh, it's right there. 4.143. And the median of 3. And you tell your neighbor which measure best represents the data. Here's where I'd go to. I would go up here and figure out the shape of that graph first. You know, I would figure out the shape. What is the shape of that graph? Skewed, right? So what is the best measure? The median. Why? Because the data is skewed. Because the data is skewed. But would you also believe that there's some possible outliers on this guy, right? So I know a lot of you are involved with sports and activities. It might not be baseball, but I'm sure you've at least seen some games in any sport to where it's like, dude, we played a horrible team and kicked their butts, right? You know, you see one of those games, they scored 12 runs, right? That's a possible outlier. And I said, okay, what would the data look like if we got rid of that? You know what I mean? If we got rid of that. So if we go back to the applet, right, where we were at, and you see you go up here to your data, you got to delete the 12, right? They're asking us to do that. So go back and just delete and hit begin analysis. And it usually asks, are you sure you want to do this? It's like, yes, I would like to do this. And then the data should change. So it got rid of the 12. And they ask us, what's the new mean? What's the new median? Just like we did on the activity today. So here was our new data compared to our old data. That's the thing where you probably would want to write it down if you were doing it on paper, you know, so that way you can compare them. Because once you delete it in the applet, it's gone. Your only other option is to have two applets open side by side to compare them, you know. But here it is. It says, what do you notice? Let's just talk about the means. What happened? The mean went down because we got rid of what kind of outlier? A high outlier or a low outlier? So shouldn't that make the mean go down, right? You know. What about the median, which is the middle? What happened to the middle? Yeah, man, the middle stayed the same, right? You know, the mean decreased. The mean decreased while the median stayed the same. The mean decreased while the median stayed the same. Because we have amazing brains, before I kind of tell you why that's true, let's see if you can figure out why. I would have known that would have happened. If you got rid of an outlier, why would the mean change, but the median mostly stay the same? Discuss with a neighbor. The word that describes what we're talking about is resistant. Which one of those resisted the change? Did the average resist the change, or did the middle resist the change? The middle resisted that, right? Are you with me on that? The middle said, you do not affect me by cutting off one of the ends, right? I'm in the middle. You're not going to change me. It might change a little bit, you know, but it's not going to move much. But man, when you change the average, you cut off a high value, that's going to change it. So a resistant is a measure of center is resistant if it isn't influenced much by extreme values. My age is an extreme value in this classroom. It is going to change the average drastically, right? But it ain't going to change the middle of the data, right? So the median resists me. It's like, yeah, it doesn't matter if you're in here or not, bro. The middle's still going to be 14, right? The middle's going to be 14. But the average, it's like, man, if you take me out of the classroom or put me in here, the average would go up to like 17, 18, which has nothing to do with like what our data looks like, right? So resistance. So let's kind of see what we got here. Yolanda has scored these 11 scores. Hey, check it out. That's a lot of tests and quizzes, right? She's taken 11 of them, right? And she's got an 87, a 70, a 78, and etc. Find and interpret the median. Put them into the applets, right? Put them into the applets. So we'll go back and we'll copy this for Yolanda's quiz scores. I'll go to my applet, and if you just scroll down to the bottom and go back to menu, you could have also, since you were still in the correct applet, let me go back to that if I can, you could have just like went up here and deleted all this data out and pasted the new data in. That would still work. The time to go back to the menu is when you like really like are changing. It's like I'm not doing one quantitative variable anymore, so that's what she looks like. Hey, isn't that fairly uniform, though? You know, it's still 11 quizzes is a lot of quizzes. If I made you take 11 quizzes, you'd be like, bro. But it's fairly uniform because it's not that much data. But what's her average? 82.36. And what's her median? 83. So we'll record those. Right? Find and interpret the median. So you don't have to write all this down if you don't want to today. If we understand it, I'm cool that you don't write it down. Like the median is the middle, so about half the time she scored better than an 83, and half the time she scored worse. Half the time she scored better than an 83, and half the time she scored worse. And then how about the mean? If you're going to write something down, what word are you going to put in there for mean? You're going to put the word? That would be median, right? You know, I want mean. You're going to put the word average, right? Her average quiz score is an 82.364. And by the way, these were her stats quizzes. So she's doing all right. She's got a B, roughly, you know. She's doing all right. But I'm sure you've known a student, maybe it's happened to you before also. It's a horrible thing where you miss class and it's unexcused. And there's just no way to make it up, and you got a 0 on the next one. Let's talk out loud. What's going to happen to her average? Way down, right? You know, it's like, oh my God, you just got a 0. What's going to happen to her middle? Probably not much, right? You know, isn't that 0 an extreme value on this one? So let's go back to the applet and put 0 in for another score. Make sure you have a space, right? And put 0 in for another score. And again, you might have had to write these down if we didn't have them written down to kind of talk about it on homework of how things changed. But begin analysis, and bada boom, yes I would. And there's that 0. You can see it totally skewed the data. Even though it wasn't having a peak or anything, isn't there this huge gap in the graph, right? You know, totally skewed the data. Her average went down to a 75.5. She was at an 82. It didn't affect the average as much as most people would think. That's because she's taken 11 quizzes already, and this is the 12th. If you've only taken 2 or 3, that's going to drastically drop you, right? You know what I mean? But it's just like she's got a decent amount of quizzes. So let's just do it out loud. We've recalculated all that stuff. I think you get it. Which one was resistant? Which one was resistant? Was the mean resistant or was the median resistant? It's kind of a weird concept. It's the median. The median resisted the change. The median, it did go down, right? It went to 82.5. Woo, went down a half a point, right? Not much, but didn't the average go down like 5% in that case? So that's a big drastic one. So let's fill in the last thing. The blank decreases more than the blank. we're going to put median and mean in those blanks, right? So which one decreased more? The mean decreases more than the median. The mean decreases more than the median. This is because the blank is resistant to outliers. Who was resistant? The median. What do you think? Not too bad, huh? These are measures of center: mean, median, and mode. Cool? Oh, wait, there is one more question. So I like to do it because there's homework questions like it. The following histogram shows the distribution of lengths of words in Shakespeare's plays. Find the median. People are like, excuse me? Have you ever heard of, like, Hamlet before? You know, Shakespeare play. To be or not to be. Aren't those some words in Hamlet, correct? How many letters in that word? How many letters in that word? That word, that word, that word. You see what they're doing? They like look all the words in Shakespeare's plays, right? And they totally just counted them up. Another, like, I know this is not our stats class, but I stole this from a stats class. Another experiment they do is they ask, hey, does Beyonce write her own music? And what they do is they look at all the words that are in her songs, and then they look at all the words in her vocabulary that she speaks on a normal basis, and they compare the two. You know, it's like, hey, she normally speaks like this, and all of a sudden in this song, you know, here's some words like this. You can kind of use word length to determine, do people use these words a lot, or are they having other people think of them for them, kind of stuff. And the truth is, Beyonce does not write her own songs, but still, you know, so is that all right? So she has some writing, but she has other people that help her. But check it out. The following histogram shows the distribution of the length of words in Shakespeare's plays. Find the what? Find the what? The middle, right? So we don't have data to put in the applet. Check this out. What is on the y-axis? It is the percent. So what does it all add up to be? 100. Where's the middle? 50%. We got to find where 50% lies, right? And this is a horrible histogram because it's tough to tell, so like how high this is. But are you cool that like there was like 5 words that had one word length? Are you with me? Or 5%, excuse me. 5% of the words had one word in it. Like A was basically that word, you know. And then how about here? It's like people are like, where is that? You know, where is that? Since it's a percent, you could call it 17.5 if you really wanted to, right? You could call it 18, so I'm just going to call it 18. And then here, you might want to write these numbers on the top of these bars. Where would you call this? 22 or 23, one of those two. Are you with me on that? Hey, add those up so far. You can use the calculator, of course. How much percent do we have so far? What is it? 45, is that right? So we're trying to get to what percent to get to the middle? So regardless of this has 23 or 24 or whatnot, is the 50th percent in this bar? What do you think, yes or no? So where is the middle at? What is the number of letters in the word that's in the middle? 4. And how I did that was I had to count up all of the frequencies on that histogram to get to the middle, which is 50. If it wasn't about percents, you'd have to figure out how many total things in there. Like if there was 70 like total students in a thing, you had to find the 35th student. Does that kind of make sense? So that's how you find the middle. All right, that's what I wanted to show you. Let's have some homework.